We are back with number 3, and we're going to do a problem where we're actually given the raw data. So it says it's believed that a stock price for a particular company will grow at a mean rate of $5 per week. An investor claims that the stock will grow more slowly. So changes in stock price in dollars are recorded for 10 weeks and are as follows. Test the investor's claim the stock will grow at a mean rate less than $5 per week using a 5% significance level. Assume weekly growth rates are normally distributed. All right, so the first step, if you're given the data, is to enter it in your calculator. And I've taken care of that already. So if you wanted to pause and enter that data, you're going to enter your data, and you can just use L1. So you'll enter the data. And then when we run our tests, we'll be ready to go. All right, so the hypotheses. An investor claims, so we can put that claim, that the mean rate of growth, so the population mean, will be less than $5 a week. So less than, so our left tail test. The null hypothesis equal. So we'll start with assuming that mu naught is $5. On our picture, we'll assume the mean is $5, unless we get some evidence to the contrary. All right, so in this case, they gave us data. So they gave us sample data. So I would know the sample standard deviation if I have sample data, but nowhere in that problem did they give you population standard deviation. So sigma is unknown to us. So that's why we'll do a t-test. And the only other value I need then to record here is my alpha. So alpha is 5% over 0.05. And let's go ahead and run our t-test. And I'm going to record the sample mean and then also the test value. So we'll run our t-test. So when we go to our tests, t-test, now that I have data, I'm going to switch my input on the calculator to the data option. I'll still enter my mu naught. The data is entered in list 1. Frequency is 1. You never change that because there's one of each number. That's all that means. We do want to switch ourselves to a left tail test less than the mu naught number and calculate. So I'm going to write down my x bar. It comes out to be 3.6. There's my sample mean. And to know where that is on the graph, we graph its corresponding test value, which is t in this case. And t there is negative 2.492. Negative 2.492, sticking with 3 decimal places for our t's. And then, just for a change, I'm going to do my p-value method first. All right, so for my p-value method, center there, mu naught is 5. And all we graph on the t-axis here is our test value, so negative 2.492. So there's my test value. And so that tells me that my x bar of 3.6 is there on the x bar axis. There's my 3.6. So that little area out there, it's a left tail test. So that area to the left of my test value is my p-value, which is looking pretty small. Let's see exactly what it is. The calculator, well, we'll round it, but the calculator says that that p-value is 0.0 0.171 or 1.71%. So for the p-value method, we compare that size, 1.71%, to alpha, which I believe we set up there was 5%. So my p-value is smaller than alpha. And technically, we say less than or equal to. It doesn't matter if p-value is less than or equal to or just less than, but we'll stick with this. P-value is smaller than my alpha. And we know that when our p-value is low, we let the null go. So when your p-value is lower than your alpha, you let the null go. So we do have evidence enough to reject our null hypothesis. So the p-value method is definitely easier, and it's what people use currently in the world. People don't do traditional method anymore. So just like we started this chapter 8 with, I showed you a research article with a p-value in it, and that's generally what you see when you read research. But we are doing both methods because you are in a statistics class here, and hopefully it also helps you understand this whole process of hypothesis testing. All right, so it's a left tail test. So the area left of the critical value will be alpha. And because it's a left tail test, the critical value is a negative number. It's be on the left. So alpha is 0.05. And to do the t distribution, we need degrees of freedom, n-1. And I didn't write down n yet, but there were 10 numbers there, and I can see it on the screen, 10 numbers. So degrees of freedom are 9. So because it's a left tail test, on the table, you would go to one tail alpha, and you would go down to degrees of freedom 9. But the table is going to give you a positive number. You need to remember that the critical value is negative for a left tail test. If you have inverse t on your calculator and you do it correctly, it will give you the sign of your answer as well. So because it's area left in a left tail test, we just inverse norm alpha. I'm sorry, inverse t alpha, and we need to give the calculator the degrees of freedom. So I'm going to use my calculator so you don't have to watch me jump back and forth to a table. All right, so it's negative 1.833. If you're reading the table, it won't put the negative in for you. So you do have to just remember that for left tail test. You'll read the table, it'll say 1.833, and you remember to put the negative in yourself. All right, so just approximating there. So there's my critical value, negative 1.833. And so my alpha is the area left of that. And the t values in that shaded area represent your critical region. So the unshaded area is your non-critical region. So a little bit more involved in the setup there for traditional method. And then we graph our test value. So that was out here. And that told me that 3.6 So there's 5, there's 3.6 is there, hitting the shaded critical region. So my test value falls in my critical region. And we know that when your test value is in the critical region, you reject H0. And that matches our p-value method, because when your test value is in the critical region, it means your p-value area, that little p-value area there, is smaller than your alpha area. Okay, so at a 5%, yes, at a 5% significance level, if we reject the null, there is support for the claim. So there is enough evidence to support the claim that the mean stock price will grow at a rate, and that was grow at a rate less than $5 per week. All right, so there you have it. Left tail test when you are given problems with the original data. So just please note, if you're given data, it might be a t-test, they don't give you sigma, but if you have data, it's possible they do give you sigma, and then you do a z-test, but it would be handled the same way on the calculator. You would just switch your input to data instead of statistics.